And hello, everybody. My name is Celia Emil, and I'll be moderating the expert clinic on probabilistic linkage. And to not lose any time, I'll pass on the word to my colleague from UNSD, Samrat Maski, who will give a very brief introduction on the topic. And let me very quickly find your presentation so that I can share. Can you see it in full screen, Samrat?
Yes.
Oh,
Thank you. Thank you so much, Celia. First of all, welcome to all the members of the collaborative on use of administrative data for statistical purposes in this expert clinic on probabilistic record linkage. I'm Samrat Maske from UN Statistics Division, and I support the collaborative with main focus on tax team 3 on technical interoperability and linkages. And one of the main scopes of the work of this tax team is data linkages. Next slide, please, Celia. Thank you. When talking about data linkage in general, there exists two levels to it. The first, an aggregated level that matches that often referred to as a statistical matching that links aggregated level of data like population, group, or geographic location, or so forth. It may not necessarily correspond to the same entity level like person, but linking them would be easy and requires less resource. A more granular level linking, often referred to as record linkage, links record at entity level like person, enterprise, household, and so forth. And through this, you can link two or more data sets. And then within it, there are two standard ways to link the data. One is deterministic and one is probabilistic. Next slide, please. If we just visualize it, the data linkage would have group level matching and exact matching. And then the exact matching can be done using a deterministic and probabilistic linkage approach. Next slide, please. I think we're very familiar with the deterministic record linkage that uses unique identifiers like social security or national identification code or similar variables among the different data sources to link the record. It could be a combination of similar variables to generate unique identifiers to link the record as well. But sometimes we do not have same unique identifiers across data sets. And that's where we may try to make use of probabilistic record linkage. Next slide, please. When talking about probabilistic record linkage, it is a technique that uses statistical methods and algorithms to assess the likelihood that the two records from different sources refers to the same entity. It assigns the probability to pairs of records being matched on similarities in attributes like name, address, date of birth, or other identifying information. And these similarities are often expressed in the terms of similarity score or weight. And the mathematics for it goes back to the groundbreaking work of Newcomb around 1959 and Shuttle around 1969, who formalized the theory of probabilistic record linkage. Next slide, please. Basically, typical steps that are involved when doing a probabilistic record linkage involves pre-processing the data to ensure consistency and uniformity across different data sources. Then blocking could be used to group records so that we could narrow down the potential match and make the comparison more efficient. Then comparison methods like string matching or distance metrics could be used to compute the similarity score. And then based on these, a threshold could be defined to set or to decide whether the pair is considered a match or not. Finally, we can do the evaluation and refine the overall model to improve the overall accuracy. Next slide, please. There are many tools and libraries that support these methods that I just highlighted. And in this slide, I have listed few of the free and open tools in different languages like R, Python, and Java. Let me just highlight one or two of them. Realis is one of the tools. The first one that is a record linkage at ISTAT. That uses the that could be used for probabilistic record linkage, and it has its own graphical user interface, and it's a free tool. The second tool I just wanted to highlight is the FastLink in R language that implements the Fehling-Schuster probabilistic record linkage model. And Data for Now project provided a training to DANE Colombia on this library, and the codes and the recordings of these are available in the UNSD's Data for Now page. And I'm really happy and very excited today that we have a presentation on a very popular Python library, Splink, and its use case in National Statistics Office here today. Next slide, please, Celia. These are a few of the resources and references. And with this, I just hand over to you, Celia, and look forward to this expert clinic. Thank you.
Thank you, Samrat. Thanks very much for this introduction. And without saying much more, I'll hand over. You already mentioned Splink. So our first speaker is Mr. Robin Lineker from the Ministry of Justice in the UK, and he's a data scientist and I think the lead developer of the Splink tool, and has been leading the work on data linking and methodology at the Ministry of Justice. Thanks so much for presenting here, and I'll hand over to you.
No problem. Thanks very much. Can you hear me okay? Yep. And you can see the screen?
Yes.
Excellent. Thanks for the introduction. So I'm Robin. Yeah, I work at the Ministry of Justice here in the UK. I'm going to be talking about Splink today, which is our library for doing probabilistic record linkage. So we're really excited about the software we've been developing for the past few years. I think primarily in two areas. So first, it makes linking fast and accurate. So it even allows you to link very large data sets of tens or hundreds of millions of records. That was the primary reason we built this software, because something didn't exist for free that did that before. But the second thing that's important about Splink is it implements statistical best practice. So it produces a range of charts and interactive outputs that help you as statisticians to understand and quality assure your linkage work. So this has really enabled a step change in our ability to perform high quality and timely linkage across some of the Ministry of Justice's largest administrative data sets. It's also worth noting that this isn't just about justice. Splink is a very flexible software library. So it's designed for a broad range of record linkage and deduplication tasks. Not just the person entity either, so you can link any entity type with it. And it also works on a variety of different IT infrastructure, because we know that across countries and across government departments, people have like totally different computer systems. So just a very quick overview of what I'm going to talk about today. So we're going to cover what Splink does, what we've used it for, and then a few details about how you might want to use it yourself. So you'll probably all be quite familiar with the core problem of record linkage, which is that we have either one or several tables that refer to the same entity. So in this example on this slide, the entity type is person. And the problem is we don't have a unique identifier. So we don't know for sure whether these people are the same person or a different person. And because we've got lots of different data entry systems and all that sort of stuff, it's very common for there to be data entry errors and differences between these records. So this person might have like moved city from London to Manchester. We might have blanks, we might have misspellings, that sort of stuff. So like most data linkage software, Splink will produce pairwise comparisons of those records. So setting two records against one another and then giving you match scores. So that's an assessment of how likely those two records are to refer to the same person. In addition, it's able to cluster those pairwise match scores together to produce an estimated unique identifier for each person. So in this case, it's decided that those 3 people are indeed the same person, and it's assigned them all the same estimated cluster ID 1, so that you know that those are now all of those different identifiers on the left-hand side, blue 1, blue 2, and red 1, all in fact relate to the same person. That scoring it does by estimating the Verleggi center model, which was just mentioned. It's able to do that in an unsupervised way, so you don't need training data, and it does that using an implementation of the expectation maximization approach. So none of that's particularly novel. As I think was mentioned, this theory has been around since sort of the 60s. But once we've got our match score, we're probably interested in understanding what the software has done and whether we can trust those results. So let's just have a look now at some of the graphical outputs of Splink that help us actually understand what's going on under the hood, what's going on in that underlying statistical model. So we're going to start with this waterfall chart, and this chart explains how the link score was computed for the comparison of any 2 specific records. So for this example, we're going to use those 2 records at the bottom of this slide, this person called Lucas Smith, who I just made up. So in the waterfall chart at the top, what we have is on the y-axis, we have match score. So the higher you go here, the more kind of likely these records are to be a match. And on the x-axis, we have all of the different things that we know about this person, their first name, their surname, their date of birth, and so on. And we're going to read this chart left to right, and it's going to tell us how it incorporates each of those bits of information. So on the left-hand side, we start with something called the prior. That's like a prior in the Bayesian sense. So that's the probability that any 2 records from this data set taken completely at random are a match. That's typically a small number. So, you know, if you take 2 records at random, it's unlikely to be a match. That's why we're starting in this negative territory below the horizontal line. But then we observe in this case that Lucas, the first name, which is Lucas, it matches. And so Splink has estimated a match weight associated with the fact that first name is a match. And that in the waterfall chart, we're going upwards then. So we're increasing our confidence that this is a match. And then this thing, which starts with TF underscore, that means term frequency underscore. We're making a further adjustment for the fact that it's not just a match on first name, but Lucas is a relatively unusual first name, which means that we're even more confident that it's a match. In the UK, John is a very common first name. So if the first name had been John here, that term frequency adjustment would have been downwards. The surname here is Smith, that matches again. Oh yeah, and here we do have a downward term frequency adjustment to reflect the fact that in the UK, Smith is a very common surname. I think I'm getting a bit of...
No, you mute. Oh, okay.
Yeah, we're good. Yeah, okay, sorry. So we got up to Smith, right? In these 2 records, we can see at the bottom here that date of birth does not match. So that's evidence against these 2 records being a match. We can see that reflected here in the negative match rate associated with date of birth, which isn't a particularly strong negative match rate because the ages of these 2 people are quite similar. And similarly, we've got a negative match rate associated with city because it looks like this person has moved. Again, that's not a very strong negative match rate because people move around. So if you see 2 entities and they don't live in the same city, but maybe those records were collected a year apart, so they might still be the same person. And then finally, there's a very strong match rate associated with the match on email because email is a very strongly identifying characteristic. So in this specific example, we end up very strongly in positive territory, and the model has concluded that these people are almost certainly the same person. So in addition to understanding how specific pairwise comparisons like the one we just saw were made, we can produce summary charts of the linkage model as a whole. And for those of you familiar with these models and the terminology, these are representations of the M and U probabilities. One of the uses of these charts is to check whether the estimated model parameters are intuitive. So we've estimated a model, does it make sense? And so in this instance, we can see that, I think there's a pop-up, yeah, on the next slide there. In this interactive pop-up, we can see that there's an exact match on city here. And this tiny text at the bottom says that if the comparison is an exact match, then the comparison, if the comparison on the city is an exact match, then the overall comparison is 10.5 times more likely to be a match. Now, that's the estimated parameter, so we can check our intuition against that. If in this data set there are around 10 different distinct cities, that sounds about right. If there were thousands of cities, that would sound like something had gone wrong. So if we know our data set, we can use these charts to immediately decide whether the estimated model parameters seem to be about right. We can then combine all of this into a heavily interactive dashboard, which we call the comparison viewer. And this really speeds up the quality assurance process by selecting example record comparisons from right across the spectrum, from non-matching pairs through to uncertain matches through to strong matches. And this allows us to quickly see the distribution of match scores and then drill down into specific examples to see a waterfall chart. And we find that this is one of the fastest and most effective ways of checking whether the model's working. We also, if you're kind of familiar with record linkage and some of the issues, you'll know that graph algorithms come up quite a lot in record linkage, particularly when you've got multiple duplicates. So we also have an interactive dashboard for the graph outputs that come out of Splink, which we call Splink Cluster Studio. So this shows you some example clusters from your linkage as a graph. It allows you to click on the different edges and see what's going on, change the match threshold and see how clusters kind of spring apart and come back together, that sort of thing. So it's another tool for helping you understand the results of your linkage. And finally, if you have labeled data, there are tools that allows you to do formal accuracy analysis. So that's things like receiver operating characteristic curves, precision recall curves, that sort of thing. Just wanted very briefly just to cover a few more features of the software that maybe differentiate it from other options. One of the most powerful features of Splink is the user is in complete control over how records are compared. So you can use fairly standard fuzzy matching functions like Jarrow-Winkler or Levenstein. But say you were dealing with geospatial data, you could get more sophisticated and you could estimate different match weights, not just for an exact match on postcode or zip code, so the address, but you could also say, well, what would the match weight be for postcodes which aren't exactly the same, but they're within 5 kilometers of each other? Or if a person has multiple postcodes, they've been at multiple addresses, you could store those as a list and ask whether there's some overlap in that list. So you have a lot of flexibility there. Another feature of Splink is that you can perform both batch and real-time linkage. So that means that you can link your 10 million records overnight. But if you just have one more record and you want to know what it links to, you can do that in sort of about a second. And overall, a key design philosophy, I think, of Splink is to enable reproducible data linkage work. So one part of that is after you've estimated your model parameters, you can actually save that model to a little .json file on your computer. You can share that with other researchers or statisticians, and they can then produce identical results. So just very briefly, how Splink has been used at the Ministry of Justice. So really, we started working on Splink to help us modernize record linkage at the Ministry of Justice. So we had tens of billions of records of administrative data, and we've now used Splink to link all that data together, and the resulting data sets are actually now available to academic researchers to use as part of something called the Data First program. And that's being used to create new evidence on repeat users of the criminal justice system, so people who keep coming back to court or keep going back to prison, and also interactions between different parts of the system, maybe like the probation and the prison system. In terms of how Splink has been used, so we do use it at Ministry of Justice, but we very quickly recognize that this is just such a pervasive problem that crops up in many different places, like almost all big organizations have a record linkage problem. And that was really why we decided to build such a general tool that's intended for widespread use rather than just for us at the Ministry of Justice. So we made sure that Splink's very flexible. It makes no assumptions about the data you're working with or the entities you're matching. And this has turned out to be really popular. So it's now been downloaded over 7.8 million times. It's in use in other government departments in the UK, including our Office for National Statistics. Also other international central statistical bureaus in Germany, in Australia, and New Zealand have also tried it. We're also aware of its use in the American Department of Defense, the European Medicines Agency, Stanford, Princeton, and even like private sector companies like Databricks. And not only is it being used by quite a lot of people, it's very collaborative. So we've actually had substantive contributions to our software, for instance, from the Australian Bureau of Statistics and 36, I think, other contributors, including Databricks. And there's a picture on the slide, but there's even an O'Reilly textbook that's been written on Splink that's actually out in a few months. So hopefully I've done a reasonably good job of explaining why you might want to use Splink, but just a quick bit on how you can get started. So I probably haven't said it yet, but Splink is free Python software. If you're familiar with Python, you can install it in the usual way, just using pip install Splink. That'll work fine on your laptop. You don't need any special like cluster computing or anything. If you have data sets of maybe up to 2 million records. If you have like really massive data sets, you know, like 10 or 100 million records, Splink is compatible with big data tools like Apache Spark for AWS Athena. In terms of supporting international colleagues, like the people on this call, yeah, we're just really keen to support people to use this and get value out of it, because we think it's just got so much value more widely than the Ministry of Justice. So if you'd like some help, you just want to chat to us, please do reach out. My email address is on the slide, or just you can probably find me on LinkedIn. And finally, just to give you a flavor of what Splink actually looks like. So it is a code-based tool. You have to write Python code to use it. And that was a deliberate decision to ensure linkage is reproducible. But we recognize that also makes it harder for some people to use. So we've really tried to minimize the amount of code that you have to write to link data. So like, I'm not going to read this code in any detail, but this just gives you a kind of sample of how much code you need to run your linkage model and get some results. So hopefully that doesn't look like too intimidating. It's not a huge amount of code to link potentially a very large data set. If you want to get started, we've got lots of tools to help you. The first is a documentation site. I'll put the links to this stuff in the chat in a moment. And the second, there's a live interactive environment where you can just try Splink out in your web browser, so you don't really need to install anything. And we really find that a lot of users get started by running through some of those interactive tutorials on some fake data, just to get a flavor for what Splink does. I think that's all I have time for, but I'm very happy to answer any questions if there's any time for that. But thank you all for listening.
Thanks so much, Robin. And I'll ask you if you have questions to either post them in the chat or write them down. We'll have a round of questions in the end. Thanks so much for the presentation and also making it very accessible. I'm not a data scientist, and I didn't get scared away, and I feel yeah, like I can have a look as well. Yes, so from the general Splink model, we'll now hear about the usage of it from the Office of National Statistics of the UK, and I'll pass the word to Prad. Oh, I'm really sorry if I mess up your name, and please correct me. It's Pradibha Velanki.
Yeah, that's
yes.
good. Thank
Good.
you, Celia.
And I'll also try and share your presentation. Just give me a...
That would be great, because I am not able to. And sorry, for some reason my video is not working as well. And
Yes.
apologies for my voice, because I've got a cold and cough.
I don't know why it doesn't want to share. I'm ending this one. Second try. Can you see the presentation? And then I just need to put it in. Oh, do you still see the old presentation?
We can see the presentation, yeah.
Right. Okay, great. Then I'll hand over the word to you.
Thank you, Celia. So just a brief introduction, I'm here to speak about Splink and its use at Office for National Statistics UK. I'm Pratibha Velanki, and I work in the data linkage team in methodology of ONS. Next slide, please. So in the overview, what I'll cover today is the usage of Splink in ONS. So broadly, how is it being used, and what sort of projects and configurations, etc. And a specific case study of using Splink for census overcount estimation. It's a project we've done a couple of years ago, but it's the first real usage of Splink in ONS. A bit old, but still relevant. Thank you. Next slide, please. So now we'll look at the current projects. So some of these three are the most important projects that we are currently using Splink for. The first one is for the build of the demographic index, which is an administratively linked data set for England and Wales. Splink is being used to link 6 sources of administrative data sets over time, about 6 years, some of them, to a linkage spine. And this is done following a deterministic matching rules to increase recall. The second project where Splink is being used is for the linkage of census and CCS to the demographic index for quality assessment of the demographic index. This is to look at if United Kingdom can move from census to admin-based demographic estimates, and to look at what is the current quality of the administrative demographic index as compared to the census CCS in 2021. The third project is for developing a generalized method for linking the demographic index itself to any other relevant administrative data sets so that analysis can be done and policy can be proposed for areas that the government is interested in. Next slide, please. So some of the key things that are relevant for ONS at the moment is we are still using Splink, which is less than version 3. This in the slide that Robin had shared, it's the latest version of Splink, and we're still currently trying to get that to work in our projects, and we're not quite there yet. But we've always, again, used Splink as a component of the linkage method rather than as the whole method itself. So it will always be used in association with some sort of deterministic matching, followed by some blocking, and then Splink in order to increase recall or to support clerical in some way. And recently we've researched a way to automatically detect a threshold. This is in the setting where Splink is used when a gold standard is available for that linkage, and also where Splink is being used to increase the recall of the method following deterministic matching. Next slide, please. So moving on to the case study, it's the census overcount estimation. The rationale behind this project is that we're trying to link census to census to look at what is the overcount estimation in census forms, and we want to basically test the effectiveness of an alternative census to census matching method against ONS's own automatic checking algorithm called ACA. ACA is basically followed by Feliki-Sinter's implementation of probabilistic matching, and together with ACA and Feliki-Sinter, Census was using these methods to kind of estimate the overcount in 2021. Splink was chosen due to the streamlining of the probabilistic linkage process. It made the whole process even more easy and smoother. And we were able to test against the output of census to census 2021 data from ACA. So we had a good standard to check the performance against. And we were also able to address some of the previous challenges that we were facing without Splink, and Splink was able to support with that. Next slide, please. So not going into too much detail about the method itself, but basically the ACA takes candidate pairs above a certain threshold, which were linked using Feliki-Sinter, and they were linked on some key variables like forename, surname, date of birth, and sex. And what was then done using ACA is use some secondary variables like ethnicity, occupation, marital status, etc., to see if some extra pairs could be either accepted, rejected, or sent for clerical review. This was done basically to smoothen the process of clerical review and to make it easier. Next slide, please. So here's a summary of Splink, but I think Robin's done a brilliant job already of it, so I'm not sure whether we need to go through it. But yeah, like it's basically probably worth repeating that it uses individual models alongside expectation maximization algorithm for parameter estimation. It it combines estimates into a final model, and it uses Feliki-Sinter essentially to compute match score probabilities. So that's always relevant to our work. And the parameter estimation happens at multiple levels of agreement, and it requires M and U values, which people who are aware of the method will know, but they are the parameters for each of these different level of agreements. We'll have a quick look at it hopefully in the coming slides, but next slide. This would be the general workflow that you can expect to use Splink and to have your probabilistic matching done. This is a workflow when a gold standard is available, but there's only one minor change which I'll mention if a gold standard is not available that you would have to go through. So you'd create a great gold standard. In our case, we did that from the ACA. Calculate a prior, which is in our case, what's the likelihood that a record is a duplicate? And then case statement creation, which is you define all the levels of agreement, and following that, you calculate the M&U values. You create a blocking strategy so that Splink can run efficiently on the likely pairs of matches. Run the final model of Splink, and you do some sampling, clerical review so that you can determine a threshold, or in our case, it was in what range of scores are census overestimates likely to exist, and what are the likelihood of that estimates. So next slide, please. Sorry again. So yeah, prior calculation is an important step. Again, usually it is the probability that a record pair picked at random is a match. And sorry, I think it's how many record pairs are truly a match in the data set. Yeah. But in our case, because we're looking at census overestimates, so census to census duplicate present in the data set. So the prior is the probability of pair picked at random being a duplicate, and it's approximated by the formula given below. As Robin mentioned, usually the prior is very low, small value, and yeah, it's that's the same in our case. What we've done in our method is use the gold standard to compute the M and U values. U values, Splink can do that automatically, but we use the gold standard to just estimate the M and U, M values. Next slide, please. These are some examples of the case statements and M and U values. So they were on the left is the table where you have first name, surname, middle name, etc. All the variables that you could define the case statements on and that we used for our method. And further along, for each of these variables, you define different agreement levels. And you can see an example for the first name where 4 levels have been defined, where at the first level, it's Jaro-Winkler similarity greater than a certain threshold. And then following is transposition, Levenshtein distance, etc. And you can define these are user definable and customizable, but also Splink, I think Splink version 3 now has the ability to also automate some of these definitions. And you'd calculate M and U values on each of these agreement levels. Next slide, please. The other important step is blocking strategy. Often we've observed that Splink needs a tight set of blocking rules, and it's often important to consider this step before running the whole model, just to make sure that we're going to capture all your links that you're looking at. So we looked at the blocking strategy aimed at capturing all the gold standard links, because we had a gold standard at the time, and then additional hard to find links, some of them. In our case, not just trying not to go into too much detail, but there were some variables that could not be the same, so it was possible to customize those blocking rules so that those conditions could be satisfied. And in all, we could use, we designed 42 blocking rules with 16 postcode transpositions in order to create our blocking rules. Next slide, please. And that's a summary of our final results, I guess. So we were able to find some top links and then ranked all those links based on the match score. The first graph on the top is the histogram of the top ranked Splink scores. And what you won't see in this graph, but it'll come in the next few graphs, is there's a small dip above 0 on the trailing edge at the right side of the top graph, which basically is the scores and region of interest for our project. And you can see that that's exactly the range where the gold standard exists. So if the gold standard is separately taken out and scored by the same model using Splink, then the bottom graph represents the score range in which those gold standard pairs actually exist. We don't expect there to be too many duplicates, so that's why the dip, it's a very small second graph appearing that you'll see in the next graph. Next slide, please. One more. Can you click? Yeah, thank you. So, so this is the range. We tried to sample records by creating buckets of scores, and in each bucket we try to sample around 1,000 clusters and then send them off to clerical so that they can be checked as to how many are true duplicates and how many are not, how many clusters basically belong to the same person. And as expected, we see that over a certain range of scores, which is say like more than 20, there's a high likelihood that the clusters in that score range belong to the same person. So we were able to do that analysis using these scores. One more slide, please. And here's where you'll see that dip. So it's quite a huge graph. The top rank scores of the whole census to census matching. But as I said, we wouldn't expect that many duplicates, and that hopefully like they're not that many. And it is true because we see that the duplicates actually lie around the second peak, which is quite small. And that's the score range in which our gold standard pairs lie as well, confirming our belief. Yeah, so this is our research and preliminary results. And if you can click one more time. Thank you. So some of the concluding remarks that I'd like to leave you with are basically these. Just bearing in mind that this was one of our first projects, so some of the things have improved with us gaining more and more knowledge about how to use Splink and make it work for the particular project and linkage that we are looking at. But also some of those things have been improved as the Splink versions have progressed, and they've been included as part of the functions available already in Splink 3, for example. So we were able to overcome some of the previous challenges using ACA and Faligi Center. There were way more steps and procedures compared to when using Splink to estimate the same overcount. And Splink it's not a package which works like out of the box. It requires a lot of tinkering. So it's highly recommended that just have a look at some of the term frequency adjustments, how they play out in your data. Look at the design of case statements to refine the levels of agreement. We also found that M values are slightly problematic to calculate, but we've gotten better about it over time. And it's usually like an iterative process where you look at the M values for the local models, and then you refine your case statements and come back to again looking at whether the M values are realistic and sensible. It can calculate U values though without any issues, but this is where more user knowledge and spending some time is important in these steps. The prior setting is also important, and that varies according to what you're trying to achieve in your project, and it can directly affect the scores and the range where it will lie. So it's important to look at that as well. And finally, as I mentioned already, it's important to capture the edge cases using type blocking rules. This is to improve your efficiency and to just make sure that you're not going to have many false negatives or miss any matches, basically. Thank you. One more, I think that's the last slide. Yeah, so yeah, if you want to know anything more about how we're using and all the projects that I've mentioned, please do get in touch. This is our inbox, datalinkage@ons.gov.uk. Thank you.
Thank you so much, Pratibha, for this. It's very exciting actually to hear from the model how it's being developed and then how you put it into practice, what your experience as a user is. So thanks again. And we have one more presentation from another country on probabilistic linkage to hear what they're doing. I know we are a bit tight on time, so I'll pass over the word very quickly to Pablo, and another name that I can potentially butcher. So it's Pablo Dubourdieu from in Uruguay. I hope it wasn't too bad.
Yeah, no, that's it. Really.
The floor is yours.
Thank you. Buenos días, buenas tardes, buenas noches para todos. Vamos a presentar brevemente la experiencia uruguaya en el uso de SP-Link para el record linkage. Voy a presentar. Bien. ¿Pueden ver la pantalla? Bueno, yo voy a hacer una breve introducción a lo que es el sistema de estadísticas de Uruguay. Y luego Antonella va a proceder con específicamente el uso de SP-Link. Uruguay cuenta con un marco institucional sólido y que le da mucha importancia al uso de los registros administrativos para la producción de estadísticas oficiales. Desde el 2020 funciona el Sistema Integrado de Registros Estadísticos y Encuestas, que está compuesto por 3 registros bases, medio estándar, también algunos tienen 4. Nosotros los 3 registros bases son el de empresas, el de inmuebles y el de población. Vamos a enfocarnos en el registro de población, en el que se registran todas las personas nacidas que residen permanentemente o temporalmente en el país, y se relaciona con diversos registros estadísticos como el de residencia, el de actividad y el de migraciones. Las fuentes de información, las principales fuentes de información son la Dirección Nacional de Identificación Civil, que es la entidad emisora de documentos nacionales. Además, tenemos información del Ministerio de Salud Pública, de nacimientos, de funciones y de RUCAS, que corresponde a las asociaciones con mutualistas. Y además tenemos información del Ministerio de Desarrollo Social con el Sistema de Información Integrada de Atención Social y otras prestaciones sociales. Bien, si bien la cédula es el documento más extendido en Uruguay, también tenemos otros documentos como pasaportes, documentos extranjeros y más de diferentes países, especialmente en el registro de migración. El desafío que tenemos es vincular a las personas con sus diferentes documentos de identidad, ya que no existe un archivo maestro que contenga dicha relación, y para esto usamos la vinculación determinística y probabilística usando variables identificadoras relevantes y el paquete SP-Link. Finalmente, esto termina en un hub personas, donde se puede encontrar el registro de cada persona con todos los documentos que corresponden asociados a un ID estadístico único. Es la tabla donde se encuentran todas las personas vinculadas, como recién repasé, y la asignación puede ser determinística, mediante el uso de documento de la persona, o probabilística con el uso de datos personales. Antonella.
Bien. Hola, buenos días y buenas tardes. Yo voy a contar un poquito del proceso de cómo se creó el Hub Personas y cómo entra acá el uso de la vinculación determinística y probabilística que lo hicimos con el paquete Spring de Python. Un primer paso fue ver qué variables priorizábamos y confiamos en su calidad y de qué fuentes tomar dichas variables para hacer la vinculación. El segundo paso es estandarizar las variables y homogeneizarlas para poder hacer una mejor vinculación, un mejor macheo entre los diferentes registros. El tercer paso es la vinculación de los diferentes documentos mediante técnicas determinísticas o probabilísticas. Y hay un cuarto paso que no voy a entrar acá en detalle, que es de validación de pasaportes para darle como un estatus de más validez. Siguiente. Bien, en el tema de priorización de variables y fuentes, lo que hicimos fue ver qué variables tenemos relevantes entre los diferentes registros que puedan identificar a las personas. Entonces tenemos el primer nombre, el segundo nombre, el primer apellido, el segundo apellido, que sabemos que en estas variables hay diferentes formas de escribirlas según los diferentes registros, porque no siempre es algo automático asociado al documento de identidad, sino que muchas veces pasa por personas que lo escriben manualmente. Luego tenemos la fecha de nacimiento, que sabemos que también puede contener algunos errores de días o meses. El sexo de la persona, que en el caso nuestro en Uruguay termina siendo una variable poco confiable según la fuente de información, es la única que estamos más seguros de la oficina de emisión de los documentos de identidad, y por eso en este caso no utilizamos el sexo como una variable en la vinculación probabilística. Luego el número de documento de identidad, ya sea cédula de identidad, pasaporte, documento extranjero o algún otro. El tipo de documento, que a veces tampoco es tan confiable, y el país de emisión de documento. La siguiente. Un segundo paso fue estandarizar y homogeneizar las variables, es decir, poder limpiarlas y tener un proceso que se corra para todos los registros, de modo de poder sacar duplicados y tener un mejor macheo entre los diferentes registros. Eso significó convertir todas las cadenas a minúsculas, reemplazar los caracteres especiales o puntuaciones por una cadena vacía, seleccionar espacios en blanco, reemplazarlos por uno solo, convertir caracteres de Unicode a ASCII, es decir, sacar los tildes y los diacríticos que tenemos en español, eliminar espacios en blanco que sean adicionales, que estén al principio o al final de la cadena, y tratar las variables vacías como nulas en el caso de que haya algo. Y el tercer paso es la vinculación de documentos. Lo que hicimos aquí fue un proceso en el que primero integramos todos los registros, en las diferentes formas de escribir los nombres, los diferentes documentos de identidad, las fechas de nacimiento, y creamos una tabla maestra de documentos. Esta tabla maestra lo que contiene es justamente eso, ¿no? Las variables escritas de diferentes formas para cada una de las fuentes. Con eso creamos clusters. Con el paquete Splink de Python lo que hicimos fue ver que hay como dos formas de usar el paquete. Una es de vinculación, otra es de duplicación. Usamos primero la de duplicación para ver qué duplicados hay, por crear clusters de registros que corresponden a una misma persona, y a partir de ahí poder generar primero una vinculación determinística y en segundo lugar una vinculación probabilística. En la siguiente se explica mejor el proceso. Bien, vemos que al principio lo que hacemos es justamente esto, sumar todos los registros, hacer una limpieza, eliminar duplicados, y también lo que hacemos es sacar registros que tengan muchos nulos, porque nos puede llevar a errores en el proceso de macheo. Con esto creamos la tabla maestra de documentos que nosotros le llamamos, que no es el hub persona, sino que es un paso previo, para luego ya con el paquete de Splink de Python poder generar clusters que correspondan a que genere un ID por los diferentes grupitos de registros que corresponden a la misma persona. Ahí hacemos reglas de bloqueo y de comparación para poder generar estos clusters. Y tenemos en un primer lugar la vinculación determinística con el registro que ya tenemos nosotros oficial de la emisión de documentos de identificación civil, es decir, de las cédulas de identidad. De esta forma podemos matchear ya por el documento o por el nombre completo más el nacimiento. Si de manera determinística alguno de los registros del clúster ya machea, le podemos asignar a todo ese clúster, es decir, a todos los registros que fueron identificados por la misma persona, el mismo ID estadístico persona. Hay una corrección en ese proceso de falsos negativos, se descartan falsos positivos, y con el resto de los clústeres que no pudieron, ninguno de los registros incluidos allí, ser vinculados determinísticamente, se pasa a un proceso de vinculación probabilística, también con Splink, en el que se hace por nombre completo, es decir, primer nombre, primer apellido, segundo apellido y fecha de nacimiento. En ese proceso también la corrección de falsos positivos y falsos negativos. Bien, bien. Esto es explicado un poquito en mayor detalle cómo es la parte de la generación de clusters, donde hay también una limpieza de las variables, se eliminan los casos con muchas variables nulas, hay una eliminación de duplicados, creamos las reglas de bloqueo, se determinan qué comparaciones hacer, genera la predicción del modelo, como explicaban los compañeros antes, y se generan los clusters. Acá tenemos un caso de un ejemplo donde hay un cluster ID que identificó 3 registros como la misma persona. Si ven, están escritos diferentes los nombres, en el segundo registro el nombre está escrito diferente, y en el tercer registro tenemos otro documento de identidad. Pero los tres son las mismas personas. Esto, lo que va a hacer una vez que tengan este cluster ID es ver primero si se vincula de manera determinística alguno de ellos, ya queda vinculado con un nivel estadístico todos esos registros, y si no, se pasa a la vinculación probabilística. Bien, esta es la vinculación determinística que se hace por documento de identidad y fecha de nacimiento en primer lugar, y después por nombre, apellido y fecha de nacimiento en segundo lugar. Y hay una corrección de falsos negativos y falsos positivos en el medio. La siguiente. Y en la vinculación probabilística usamos el Splink en el modo link only, solamente para poder vincular a los registros que nos quedaron sin ningún ID estadístico con el hub personas que ya tenemos. Bien, entonces se hace otra vez la limpieza, se crean nuevas reglas de bloqueo, se generan las comparaciones a realizar, hay una predicción de modelo con los valores M y U, y se vinculan las filas propagando el ID estadístico personas. El resultado de todo esto es que nosotros podemos tener una tabla en la que tenemos un ID estadístico persona asociado a diferentes documentos de identidad. Esto nos ayuda un montón en lo que es la vinculación de registros, sobre todo, como decía Pablo, para lo que es el registro de migración, donde acá en Uruguay obviamente se utiliza mucho el pasaporte y documentos extranjeros para entrar y salir del país. Entonces nos facilita un montón saber que hablamos de la misma persona con diferentes documentos, ya que no existe en el país una tabla que tenga la correspondencia entre cédula de identidad y pasaportes, o cédula de identidad y documentos extranjeros. Y también nos permite poder captar a inmigrantes y turistas que entran al país y poder tener los diferentes documentos de identidad asociados, a modo de poder generar nuevas integraciones entre diferentes fuentes de datos. Y ahí cerraría.
Thank you so much, Pablo and Antonella. It was great to hear another example of how a country is using Splink. And I'm so sorry for running a little bit over time. I'll very quickly open for questions. I'm not sure if Robin and Pratibha are still there. So if anybody has questions that haven't been posted in the chat, I saw there was discussions in the chat already and some things have been answered. Please go ahead. And then also, while waiting for questions, I can say this recording is going to be on the CAD webpage and also all the presentations. So you can rewatch it or share it with colleagues that have missed today's session. Yes, is there anybody that has questions? I see a raised hand. Yes, Gloria.
That's Gloria.
Yes.
Thank you. Nice to see you, Silja. I'm just wondering whether there is a comparison between this software and others that has been done to know, is it the single best software for this work? Can we consider it that way, or there are other comparisons to that? Like how do we know whether this is what to go for? Has there been some work that has been done around this work? And then a very ignorant question on my side is, I'm just wondering whether this is the software behind countries that are implementing population registers. Is it the back end that allows records to link across various registers? If someone can shed light on that, I'd appreciate it. Thank you.
Thanks so much, Gloria. Is one of the presenters keen to answer first? Yes. Go ahead.
I can give it a go. So on the first question about what's the best software, well, I'm very biased, so I won't give you a direct answer. So in terms of comparisons, something like FastLink in R will give you fairly comparable results because the underlying methodology is similar to Splink. It'll give you much less graphical outputs that tell you about like how the model is working and helping you to understand what's going on. But really, I think the key reason we developed Splink was when we're talking about population scale data, 10 million records plus, I'm not aware of any other open source and free software which will actually work at that scale. So FastLink, if you give it 10,000, 30,000 records, it'll do a good job of that. But if you give it 10 million, it'll just blow up. In terms of how it's powering other people's systems. It's in reasonably widespread use, but by no means assume that if a country is doing that sort of linkage, it's using Splink. It probably isn't in most cases, but it is in some cases.
Thanks so much, Robin. Is there one of the others that wants to add? I know, yes, just maybe Gloria as well. Samrat had a comparison chart just to give you like a very graphic overview of some of the different options that are available. And then, yeah, as Robin said, some of them might not be able to handle a lot of records, but they can maybe do some other things. And on the population register question, I think there are some countries that have unique identifiers that then don't need to use probabilistic linkage as much or to the same degree. So it's not necessarily needed for all countries with a population register. Are there other questions? Or anybody of the presenters that wants to add anything? I know we're 4 minutes over already. No? Great. Then I'll be closing the session. I just want to thank all the presenters very, very much for being here and sharing your really inspiring work. And I also want to give some special thanks to our interpreter, Jorge, who's done an incredible job with such a technical topic today. And then I want to thank you all for being here and for staying for this session. And I hope we see you again for our next meeting and expert clinic. Thanks so much and have a good rest of the day, evening, afternoon, wherever you are. Bye for now.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thank you very
Thank you.
much.
Bye-bye.
Bye.
Thank you.
Bye. Bye.